And welcome back, Hononegah, Algebra 1. Today we're going to talk about section 3.2, which is linear functions. We're going to start talking about lines. And so when I asked you, or when a teacher asks you whether or not something is a line or not, a linear equation with two variables, x and y, is an equation that can be written in the form y equals mx plus b. So if you can write it in this form, then you can say something is a line. The graph of a linear equation obviously is a line. Likewise, a linear function is a function whose graph is a non-vertical line. A linear function has a constant rate of change. I'm going to circle that one. So now if I'm looking at a picture and it is going, or I'm looking at a table in which the quantities change in equal amounts over equal intervals. So down here, what does constant rate of change mean? If something is going up and over and then up and over and it's a constant rate, we can say that then that is a line. A nonlinear function does not have a constant rate of change and cannot be put into y equals mx plus b form. So when I give you a picture and say, is it linear, is it nonlinear, explain. The first one is definitely nonlinear. But what explanation would you give? You can't just say, well, because it curves. No. You would say it does not have a constant rate of change. And I'll let you abbreviate constant rate of change as CRC, constant rate of change. Next one. This one is linear. And again, you can't give me an explanation of, well, it makes a line. If I go up 2 over 1, up 2 over 1, up 2 over 1, it has a constant rate of change. So again, this is a line because it has a constant rate of change. Table. Again, deciding, now I can't look at it and say, well, look, it's a line or it's not a line. The x values are going up by 3s. The y values are going down by 6. That is a constant rate of change. The y values are changing at an equal interval. So this is linear because that has a constant rate of change. The next one's going up by 2s. Up 7, up 11, up 15. So this is non-linear because it does not have a constant rate of change. Which of the following represents? Remember, if you want something to be a line, it has to be in y equals mx plus b form, or at least be able to be put into y equals mx plus b form. Now, this one technically is linear. Reason, it could be y equals 0x plus 3.8. So again, I can make that one into a line. This one, and I'm going to do some abbreviation only because this one is really small. Notice that y equals mx plus b does not have a radical symbol, so you are not allowed that symbol, so this is non-linear. Again, you can't have x be an exponent, so this one is non-linear again. You cannot divide by an x, so this one is non-linear. If I distributed here, this one is linear, again, because you can have that in y equals mx plus b form. This next one, you can't have an exponent. So this is non-linear, not in y equals mx plus b form. So if you are going to say something is non-linear, it's not in y equals mx plus b form. If something is linear, then you're going to say it is in y, or can be put into y equals mx plus b form. Pause for a second. You try. Tell me whether or not these are linear or non-linear, and explain. Hi, welcome back. So this is going up by 1s, up by 2s. This is linear because it has a constant rate of change. 2, Nonlinear does not have a constant rate of change. 3, linear has a constant rate of change. 4, nonlinear, I'm going to abbreviate, not in y equals mx plus b form. You're not allowed that squared term. And then the last one is definitely linear, can be in y equals mx plus b form. Deciding whether or not something is a function. In words, an output is 3 more than its input. In equation, y equals x plus 3. So I'm looking at these and deciding whether or not something is a function or not whether or not something is linear. So if it is, or excuse me, so in this first one, input to output, notice that each of the inputs goes to one output. This would be considered a function. Same as in a mapping and same as in a graph. So again, looking at this in a couple of different ways. The solution of a linear equation in 2 variables is an ordered pair x, y that makes the equation true. The graph of a linear equation in 2 variables is a set of points in a coordinate plane that represents all the solutions of the equation. Sometimes the points are distinct, or what I consider discrete. Sometimes they are connected, which would be considered continuous. We kind of talked about this in the last section. If you have individual points, those are discrete points. If you have something that's connected, that is considered continuous. So a linear function, y equals 15.95x, represents the cost y of tickets in a museum. Find the domain of the function. Is the domain discrete or continuous? Well, you can't buy half a ticket. That's what you always need to ask yourself when you're deciding whether or not something is discrete or continuous, is can I do something in halves? Can I do something in a fraction? And so this one is definitely discrete because you can only buy tickets in whole numbers. So if you don't buy any tickets, you don't spend any money. If you buy one ticket, that would be $15.95. If you buy 2 tickets, $31.90. If you buy 3 tickets, $47.85. If you buy 4 tickets, $63.80. So now, how would I graph this and what's the domain? Okay, so the domain, okay, all positive integers. And so graphing this, and again, this gets a little more complicated. I'm going to go 0, 1, 2, 3, 4, 5. So again, going across the bottom, the number of tickets. Going up would be the cost of those tickets. And I'm going to go by tens. So 10, 20, 30, 40, 50, 60, 70. And again, this is discrete, so don't connect the dots. So I'm going to change colors here to make it a little bit nicer. So 0, 0, meaning you didn't buy any tickets, decide not to go to the theater. If you buy 1 ticket, $15.95. 2 tickets, $31. 3 tickets, $47. 4 tickets, $63. Do not, I know it's going to be hard. You're going to look at this. You're going to want to connect the dots. Do not connect the dots because this is discrete, individual points. Cereal bar contains 130 calories. The number of calories consumed is a function of B, bars eaten. Does this represent a linear function? So every time you eat a bar, it's 130 calories. So does this represent a linear function? Yes, because there is a constant rate of change. Find the domain. Is it discrete or continuous? Now, can you eat half a candy bar? Yes. Therefore, it must be continuous, okay, because decimals or part of something applies. All right, so here we go. It didn't actually give you an equation, but the number of calories would equal 130B. So I'm still going to use the same XY or BC chart. If I didn't eat any candy bars, I wouldn't have any calories. If I ate one candy bar, 130. Two candy bars, 260. Three candy bars, 390. Four candy bars, 520, and so on. So I'm going to graph those. So going across the bottom, 0, 1, 2, 3, 4 candy bars. Now, increments going up. Let's go by 50. And again, as long as you're consistent, it's okay. So 100, 152, 253, 354, 455. And again, I probably could have went in by hundreds or something like that. I could have went in a different increment. 0, 0, 1, 130, 2, 260, 3, 390, and 4, 520. I am going to connect this one because it is continuous and because you can have part of a candy bar. Anytime you can have part of something, that is considered a continuous graph. Hit pause for a second and you try. And we're back. The linear function m equals 50 minus 90d represents the amount of money you have after buying DVDs. Find the domain. Is this domain discrete or continuous? Well, can you buy part of a DVD? The answer to that question is no, so then it must be discrete, individual points. And so I'm going to buy DVDs, and how much money will I have? So if I don't buy any DVDs, I actually still have 50 bucks. If I buy one DVD, 41, two DVDs, 32, three DVDs, 23, four DVDs, 14, 5 DVDs, and $5. So I'm going to graph those individual points. 0, 0, 1, 2, 3, 4, 5. Let's go by fives. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I'm going to change colors here just to make it look a little nicer. So I don't buy anything, I still have 50 bucks. I buy one, 41, 2, 32, 3, 23, 4, 14, and 5, 5. Now, what you'll also notice, again, I'm not going to connect these dots because they are discrete. Can I buy 6 DVDs? The answer to that question is no. Okay, I can only buy 0, 1, 2, 3, 4, 5 DVDs. So that is my domain, because if I buy 6, I've run out of money. I'm in the negative, so I'd have to borrow. A 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number g of gallons remains as a function of the number of m minutes. Does this situation represent linear? It is linear. There's a constant rate of change because you're going 2.5 gallons per minute. Find the domain of the function. Is the domain discrete or continuous? Can you do it for half a minute? Can you do it for 4.5 minutes or 5.5 minutes? Sure. Okay, water is draining out of this tub continuously, so it is continuous. So if I did a function here, we have a 20-gallon tank, 2.5 gallons per minute. So gallons in the tank is 20 minus 2.5 m. So I had 20 gallons minus 2.5 each minute, so that's how many gallons are in the tank. So if I don't pull the plug, so minutes, gallons, if I don't pull the plug, I have 20 gallons in the tank. If I pull the plug for 1 minute, I'll have 17.5. In 2 minutes, I'd have 15. In 3 minutes, I'd have 12.5. I'm going to skip ahead here a little bit, and I'm going to go all the way to 8 minutes. So 8 minutes, there would be nothing left. So again, skipping ahead there a little bit. So making a graph. I'm going to go by twos here. So 2, 4, 6, 8, just to give myself enough space. And I'm going to go by twos as well going up. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So no minutes, 20. 1 minute, 17.5. 2 minutes was 15. All the way down to 8 minutes. Let me try this again. Sorry, I was grabbing that wrong. 2 minutes was at 15. 3 minutes would be or 1 minute would be in between 17.5. All right, 8 minutes would be 0. It is continuous because, again, at any point here, I could go half a minute. Your homework assignment is out of the book. Good luck. If you have any questions, make sure you talk to your teacher.